I'm CSP SnowedIn. This is my friend and boss, CSP Chimichanga. So we're going to start with what the heck is Kubernetes. It was initially internal to Google for a long time. It was known as Google Borg. Google may have had some other names for it internally, but I'm not actually a Googler, so I don't actually know. They decided to open source it for the benefit of the rest of the world in June 2014, and they released their 1.0 release on July 2015. There are 715 contributors to the Kubernetes project, the core Kubernetes project on GitHub. It's got an extremely active community. There's a ridiculous amount of commits every day. You can run it in any cloud provider. It's probably easier to run it in Google, but you can definitely run it in AWS, DigitalOcean, or if you have your own VM setup or you want to run it locally, they have a lot of Vagrant stuff as well. Kubernetes introduces a bunch of concepts to deal with the orchestration of containers. The base one being a pod, which is a collection of containers that you want to run locally. It's similar to a VM, but again, we're in container land, so you got to kind of get rid of the VM idea. It's basically just containers that can talk to each other on localhost. You can't do networking restrictions between these containers. So if you have something that you want to hide, you just shove it into the pod and you don't expose that one container. You only expose one container in a pod. Replication controller will sit on top of pods. It kind of manages the pods. It will manage the scale of them, how many versions of them are running. If one of them dies, it'll just remake it. You can kill one of them manually and it'll remake it. It's great. Another thing that's similar to that is a daemon set. It's basically an RC that has a specific set of criteria for the pods to run on each node. A service exposes a container in a pod, typically. It can expose multiple ports, but it would typically expose one port. You have load balancing there between the members of the RC, whatever matches the criteria of the service. And you can also expose these service objects externally, or you can keep them internal to your cluster. There's a whole overlay network for internal to cluster services. And there's secrets and config maps, which are basically two ways of doing very similar things, of overriding files or directories in a container at runtime. So you can take a container from Docker Hub, or you can take a container that you've made and run it differently by giving it a different config at runtime using the same image. Kubernetes concepts of master and nodes is basically what we call the VMs or the machines or whatever it is that are actually running the containers themselves. The master is usually really lightweight. It is just an API for the most part. It doesn't run any containers. All the work is done on the nodes themselves. A little bit of history of Kubernetes at CCP. We've been using it for about 6 or 8 months. We started it on a OpenStack compatible API called QStack, and we managed that by sending cloud config files to manage the setup of the master and the nodes. That gave us a good base concept of Kubernetes. And then from there, we moved on to a base metal setup just to get a little bit more performance. But we needed to, or quickly found out that we needed another management node to take care of the booting of the master nodes via iPXE, sending the configs to them, basically doing what OpenStack was doing for us. And then from there, various other reasons led us to investigating running this on Google Cloud itself. There's many great hookups with the load balancers and other, hello? And their storage stuff and their APIs. Well, we're going to talk a lot more about their APIs in the short, coming up shortly. That's currently what we're running is 54 pods, 37 services across 3 clusters. GKE just came out very recently with the ability to run a cluster across multiple zones. It's getting pretty crazy what they can do.
Like last week?
Yeah.
Yeah.
On the 21st of April. So yeah, Google Cloud, what does it give us? Why is it awesome? We get fully managed and abstracted Kubernetes masters. We do not have the access to get onto our master, nor do we want it. It is completely fine running wherever it's running in Google. They give us credentials to talk to the API, and that's enough. They give us an upgrade path for the masters and nodes. If you start running Kubernetes for a while, you will realize that upgrading is not really a thing. This kind of follows a container concept, though, that you don't upgrade anything. You just replace it with a newer version. So Google abstracts that in a very nice way. We also get an automatic Docker registry created for us and stored in a GCR bucket, or GCE bucket, sorry. And all we have to do for that is just push to GCR under our project name, and it's automatically created. So that takes the burden of running a Docker repository off of you, and the fully integrated load balancer support for service objects. You do get this on Amazon as well with the ELBs, but yeah. So without too much further ado, we're going to do a little bit of live coding, and we're going to show you just how easy it is to, there we go, spin up a new cluster, what's involved. So this is the Google Cloud Console. You go to console.cloud, or if you go to cloud.google.com, you can sign up for this. Then on the side here, you just go down to Container Engine, create a thing. Let's call it Fanfest. You put it in a zone. You tell it how big the nodes you want it to be. How many nodes you want. I'm just going to go with 2 because that's probably enough. And then you can pick your network. There's a lot of really good networking stuff that you get from Google. The rest of the stuff here, you can give access to the default credential in your cluster if you want. We're not going to do that though because we're going to use a service account. So we kind of sidestep that. So now we have a cluster being made, and that's it. So while this is spinning up, what we can do is actually create that service account that I was talking about. And we're just going to make it, oh, it's still kicking around. Forgot to delete that. But anyway, it literally would have been one more button. So that's it. Now we have a credential key that we can now use for the rest of the APIs here. Another thing that you would want to do, if this is a brand new thing, you see all the APIs that you're given here. You basically can go into any one of these and then enable or disable their use in your project. So we have enabled the data store and the pub/sub APIs for this demonstration. We're going to use data store, which is an abstraction built on top of BigQuery, to do our persistent storage, because databases suck and data store is much nicer. And we're going to use pub/sub to do a distributed cache between the nodes running the web app, and the nodes themselves are just going to use in-memory caching. So it's over there. That was supposed to be on the other side. Sorry, one sec, I just have to get my notes open. Oh, cool, it's time for Nick to talk.
Is it?
Yes, about awesome GCE features that we're using.
Ah, yeah. So a lot of people have asked us over the course of talking about this at FanFest, like why did we go with Google over Amazon and over any of the other pieces? But I mean, I think this page actually sums it up pretty well. I mean, philosophically, there's some differences between Google and Amazon. Amazon, they have a store, and AWS, and that's pretty much it. I mean, they also have Prime. They do a lot of cool stuff. But a lot of what they're actually producing is not dog-fooded as much as Google is. So they don't use a lot of the services that they build internally. On top of that, there's a lot of services that they already have, which are very conducive to what we're trying to do. For example, one of those is an image server, where we can just throw images at a location and get more information back and work with those. But there's also philosophical differences between Amazon and Google in the sense that Amazon will let you do pretty much anything you want. If you tell Amazon, I want 700 machines all on a /24 CIDR, it will happily try to put 700 machines on a /24 CIDR, and that will go terribly. Google, on the other hand, they're very opinionated about their network topology. If you have any of those subnets that are overlapping or any of those pieces there, it will then tell you, no, I'm not going to online any of these machines because I don't have enough IPs to actually give those. So it's a bit of a difference. There's a lot of philosophical differences between the two. So we're also looking heavily at things like Google PubSub to kind of, as it were, an escape hatch from the monolith, from the cluster. So there's a lot of work being done now with CCP Nestor and CCP Prism X, who's going in and trying to build this pathway out of it. That way we can start building more standardized tools around the cluster. And I think there was a question in the last talk of, how are we using this at CCP? So mostly all of these are being used for, first of all, internal development services. So we're running things like CI loops, TeamCity, all of our build systems, a lot of other authoring tools for CCP are running inside of Cube at this point in time. But we're moving towards, we call these all development services, so you kind of think of them as different levels of SLAs. We're moving towards production support services, which are things that if they fall over, we don't get a phone call from the CEO saying, hey, Eve is broken, what the hell's going on? So we're slowly ramping up to those. So we're working more on things like, I don't know how much the public knows about it, but there's a system called Paparazzi, which basically takes all your wonderful character photos and then uploads them to a server somewhere. That system has been around, I feel, since before CDNs were a thing. It does really fun stuff like puts data blobs in a database somewhere, and that database is about 2.5 terabytes right now. So obviously we could do better by switching that over to a CDN, and those are the kind of things that we're slowly kind of translating into the container paradigm and the automated orchestration paradigm. And then from there, once we have these connections out of the cluster, we'll have the ability to build more things. So where we ultimately want to go with this is we want to have a standalone market service or standalone character node or whatever the case may be, and that way, during downtime, the only thing that goes down is the simulation, not necessarily the services of the game. So our ultimate dream at this point in time is that your Neocom blinks with things that are available and things that aren't available as we do updates. So we could do rolling updates to certain things, but there's a lot of gameplay implications in that. But anyway, that's our long-term goal, and that's kind of why we're using these types of services. Can I stop rambling?
Yeah.
Great.
Well done. So I'm just going to do a couple things on the command line here. We have a cluster up and running now. We have those 2 nodes ready, waiting for us to use. I've got the credentials through gcloud, and now I'm just going to deploy a few secrets to it. Remember I downloaded that credential file, so I'm just going to move that over here. So you can kind of see what we got going on here. So we're just going to create a secret. You can actually create a secret with gcloud now. This is new as of 1.2. You used to have to actually create the objects themselves, but it's way easier doing this. You can see now it's been made. That's the ship toasting gcloud secret. I don't know if you guys were on the pub crawl as Team Ship Toasters last night. But as you can see, so here's our SSO config. We're going to display it as I'm not showing you the actual secret in it, but you can see when we post this, though, that secrets aren't actually secret. You can just get them. Especially if you just output it to YAML and then do some bash stuff, then you can actually just see the secret. But that's it makes sense, right? Because the container has to see it, so it has to be clear text at some point. You can also make stuff, we just made a little config map there. Config maps don't do the base64 thing. So if you output it as a YAML, you'll actually see the plain text there of the Nginx file. I have a little bash function called random string, just generates random strings. I'm going to use that to show you that you can make a secret based off a literal value. So if you wanted to just put some stuff on the command line, this will make a file called secret with the content of that random string, which works really well when you want to do a Flask app secret. Now I'm just going to throw the fave icon up there the same way. And I'm going to put our certificates through, by using a directory, you take all the files in that directory and make secrets out of that. So there's a key pem and a cert in there. So now we have all these secrets defined. You can see what's running in the cluster here. We're going to do the rest through the dashboard. This is also new in Cube 1.2. We're going to be okay to that. Cool. You get the admin. There's basic auth on this. I'm going to like grab the credentials out, but just like in a way that I don't want you guys to know what I'm doing really, so no big deal. So I just copied the password into my clipboard. Cool. This is the Cube dashboard. It doesn't think that we've deployed an application because we haven't. There's a couple things running in the Cube system, but actually I can show you guys this. This is pretty neat. This is the actual, like, if you wanted to just deploy a thing, you could just give it a name, pull your container from somewhere, tell it how many copies you want to run. If you're going to expose a port, if you want to expose that port externally, this will make a global load balancer for you. This checkbox. It's ridiculous. You want to do labels and stuff, you can set environment variables in here. You can have, you can give it an image pull secret. That's a little bit different if you're doing, if you have a private Docker repository, you can use an image pull secret for that. You can give it certain performance things or whatever there. Another cool thing, you can override any run command, like I was saying as well. So by giving a container different configs and the ability to override the run command in it, you can really make containers do things they were not designed for at all, which is great. It allows for a lot of reuse. But I already have this actually, oh, where am I? Pretty much made up, so I'm just going to drop the YAML in here. There we go. Cool. Cool, so now you can see it here. It is being created. And I bet if I refresh this, it's probably done. Oh, I lied. Anyway, this is going to go now, and you can even edit the count here. More is always better. So let's do more.
Did we fix that?
Yeah.
Okay.
Yeah, it's all good. Yeah. So this is going to also create a global load balancer for us, and it's going to take a little while to do this. I kind of briefly touched on this earlier, but one of the benefits of using these Google global load balancers is like they will screw with routes around the world with BGP to make sure that you get into their network as soon as possible. And the Google network is rather quick, so that's rather nice that they do that. But the downside is that it takes a little while for you to know what your actual exposed IP will be. But now you can see that we have 4 pods running. You can go into the logs of any one of them, and you can actually see per container as well. There you go. There's G Unicorn starting up. It's listening on a local, it's listening on 8080 inside of the pod. And then there's an Nginx container that's being exposed on 443 and 80, which will redirect into the 8080 port, which you can't get to from the outside. So we're just DNS away from this being on the internet. There's our IP. Oh God. Copy. We're using wherever it is. It's in here somewhere.
For Cloud DNS?
Yeah, I use these little buttons instead. They're better. But yeah, we use Cloud DNS, which is pretty nice. It's just a regular-ish DNS service that we get from Google. That's pretty cheap. So all we have to do is add a record for ship toasting to that IP that we kind of copied. Create that. Cool. In a couple minutes, we will actually have a website that will actually be live and deployed right in front of you. We just need to wait. And now Nick needs to fill some space as we wait for DNS propagation.
Space again. No, but this is another good example of kind of using Cube in its native environment. The biggest things impeding kind of development speed and agility ultimately boil down to persistence, secret management.
I lied. DNS is done.
Yeah. There we go. So persistence, secret management and networking. Those are some of the main things that you constantly deal with, and Cube takes care of a lot of those. Cube inside of Google Cloud Platform takes care of those really, really well, though, because it gets to the point where you can have all of this working just at the speed that you saw CCP SnowedIn do this, and that's a huge difference for somebody who doesn't really want to care about, okay, when will this come online? So there's some manual steps that, is that Foxfour?
Yeah.
Yeah, okay. So there's some manual steps that he did here just for the demo, but there's a lot of glue that we have internally in CCP because we're using this for two different reasons. Another one of the philosophies of Google is the fact that if you online any of these services, they assume that you're going to the internet. Now, we don't necessarily want our build processes accessible from the internet, so there's a lot of stuff that we have to do on top of that to kind of prevent and clean that up in general. But mostly when you're going through and doing this, it handles the DNS, the load balancing, all those pieces together, which is really nice. But that's not to say you can't use this in something like AWS, because Cube does have integrations with ELBs as well, and Route 53, is it 53? Yeah, Route 53, to do all the coordination that way as well. So we just prefer this because we don't have to think about it, and it just kind of goes, which is super nice.
Yeah. We can take a quick look. Sorry, I was just going to dump this in DevFleet real quick. Get that dank karma.
All the stars. Did you make it public?
Yep, it's already public.
Okay.
So you can take a look at the repo that I just made. This contains everything that I just did. The kube config is right there. The demo that I just did, the typing, that wasn't actually real. That's right here too. Basically everything that you need, all that you'll have to do, the instructions are right here. Basically make yourself cert, sign up for Google Cloud, you can get a free trial, and you can deploy it in your own GKE cluster real easy. So we can actually take a look at how this stuff is being stored now in GKE. So if we go, where are you, data store? There you are. We keep our focus group logs in here too, you might notice. But yeah, here are the data store entries so far. And we can go and see our pub sub nodes should all be communicating right here. There's our 4 nodes. So yeah, that's pretty much it. And like, I wish it was more complicated, but it's just not.
How long are we leaving ship toasting online?
Yeah, like we probably won't run this forever.
Costs money.
And it's ridiculous. Please don't post illegal things. That would be super nice. It's tied to your name, so like if we have to ban you, I guess we will, but please don't.
Is it big enough so everyone can see the address?
I hope so. It's shiptoasting.tech.ccp.is.
The previous name was not acceptable for presentations. Yeah, man.
Yeah.
I think that's it. Is any questions? You mesmerized them.
Yep.
How hard is this to set up on a physical machine?
If you just want to do like a demo at home, they have the Vagrant scripts so that you can, that's one script to kubeup.sh, and yeah. So it's relatively easy for a local thing. To deploy it across multiple physical nodes gets difficult. Have a good understanding of cloud config. To give you an idea, the GKE boxes right now are all Debian based, so that would be a good starting point. But you don't have to by any means. You can use whatever you want.
And we've gone on many adventures with that. We like Sonia was saying earlier, we kind of evolved through the environment that we were in, and one of them was basically a hypervisor with a few machines on it. And from there, we were using CoreOS and kind of drinking the Kool-Aid full on to try to get everything the way we wanted. It's not, I wouldn't say it's difficult, but I would say in order to get it all automated and reliable, that's the more difficult part. to me, it was surprisingly easy. Like once you get things like kube proxy up and running and the DNS up and running, it's super simple. But like we were mentioning earlier, the having just your own private GCP account, all the quotas that are there, you won't hit any of them with kind of tinkering. So it's super nice for that.
Mm-hmm.
Have you made it working with continuous integration services?
Yeah, actually, so we run our Team City there currently, which is pretty major. I have personally run the GitLab CI runner as well. Yeah, that works really well. The one thing you might want to do is have like a dedicated Docker machine for your CI to actually build these things against. But it really depends what you're doing with your CI as far as where that load is.
So we have a bit of inception going on. We have Team City running inside of Cube, but Team City is then building Docker images, which requires a Docker host, and building a Docker image inside of a Docker image. You can do that, but it's scary what you have to turn on in order to do that. So we have a separate VM just sitting on our network for that. But then that's just constantly pumping out images to the Google Container Registry, that's the GCRIO, and then from there it's just repopulating the actual Cube cluster. So we've been doing that. I mean, we've been doing that from almost the beginning. Any other questions? Is everyone ship toasting? That's great.
Yeah, feel free if the code sucks or whatever, to send a pull request, make it better. It was just an example thing to really show how you can ship a container.
Besides the fact that you can, why? Why are you moving to
So
Kubernetes except that you can?
here, the bigger piece of this is, for the longest time, CCP has deployed the monolith in a sense of, we have the magnificent ops guys who are insane in their own very way, but basically how that has worked is we've taken a giant executable file which can morph into whatever we need it to be on the cluster and hand it to them. They throw it on some machines and turn the thing on, and if it all boots up, great, TQ online. If not, flip the switch a couple times and hope for the best. So we've been trying to kind of evolve that, and with the way that CCP is kind of diversifying, you guys have seen all the other games that we're working on, all those different projects that are coming up. Those guys need to concentrate on other things rather than just simply babysitting TQ. They've been doing that for a very long time. They've been the guardians of that for a very, very long time. What we're trying to do with this is we're trying to make it simpler for a dev to go the full stack. To not have to worry about, okay, hey ops, can I get a cert for this domain? Hey ops, can I get a DNS entry for this IP? Hey ops, can I get this IP? Hey ops, can I get this machine? You know, all this back and forth that happens there, that we can simply replace and reprioritize our guys on different priorities, allows us to do a lot more things. So that's kind of why we're pushing towards this, and that's kind of why we're slowly, we've consumed a lot of internal development services. Then we will slowly consume a lot of fucking and so we'll slowly work up to more and more critical systems, and that's ultimately why we're doing this, because I would love, like Foxfour has done this with a couple other tools for community right now, where the community is like, hey, it would be great if we could send a notification to the cluster and create the message and then just publish that. And I think Foxfour in like a day was able to just online something with this system and say, okay, Falcon, here you go. Here's a button that you can press to harass everyone. And that was done. So we want to get to the point where we can react faster to great ideas that you guys have, experimental ideas that we have, online them, offline them, turning them on and off as soon as possible without waiting for the dreaded, downtime. That's the ultimate goal that we're trying to get to.
So at this point, you're not even really considering getting rid of the monolith completely. It's more about trying to leverage this to implement secondary services, even as far as the Neocom.
Yes, in a sense. Don't get me wrong. My secret crusade is to kill the monolith. Not so secret inside of CCP, but ultimately the way that we see it, and this is kind of where we've gotten to with the technical director as well. We've had long conversations about this, but ultimately we would love to see the monolith only represent the simulation and have everything else fall away. And be able to do rolling updates for those pieces. And when I brought up the Neocom, it's more of like the market turns off because we're updating it, as opposed to the whole server goes down because we need to patch market or whatever the case may be. We have those capabilities now, but it's so much cognitive need to go in and do a surgical strike on those kind of services with the joys of monkey patching in Python. And then eventually having to keep babysitting for the next downtime to bring up the cluster again, that there's just, you're in a better place when you can open up 100 lines of code instead of all of Eve and think about that one thing and work on that one thing and deploy it and iterate on it and get those changes in as soon as possible. So it is eventually, this is our general strategy towards the monolith, and there's a lot of stuff, like I was mentioning earlier, that PrismX is involved with, that we're trying to get kind of this escape hatch so that we can get out of there and start siphoning off information, start siphoning off services, and ultimately we want to get to a point where we're doing some cool stuff there. And then there's some really theoretical stuff that we've been talking about where we could potentially even break up the simulation, but that is really far away and very hypothetical. Have you played Eve?
It really depends on the service, and like it makes sense to pull things in where that latency doesn't matter. That's why market is a good very far off thing to pull in potentially. Like where the call can take a second or two, that's fine. Google's network is extremely fast too, so us getting there is not really that much slower than us crossing our data center.
It is a concern though. So there are pieces there. We have this, I jokingly say, have you played Eve? But obviously all of us have. But the point there being is that the way that Eve fundamentally works in a technical advantage for us, because it gives us a very large wiggle room in the terms of time. If it reminds me of the days I worked on some military projects, and you have contracts coming in that's like near real time. It has to be near real time, and you're like, what the hell does near real time mean? And they're like, oh, the time it takes to go from a low orbit satellite to the surface, and it's just like, what? How long is that? And they're like 22 seconds, and we're like, oh, we're covered, we're good. 22 seconds, we got that. And that's kind of the same thing with Eve. Eve has some latency pieces, some very defensive networking layer built into the cluster itself. So we're roughly, we roughly have a buffer of 50 milliseconds right off the bat. That's not including marshaling or response times or anything like that. That's just how the internal network of Eve works. And so from that, we have a lot of wiggle room there. Now, when we get to the point of, hopefully we get to the point of this, but when we get to the point of breaking apart simulations and those types of things, then it's going to be a lot more about optimizing the paths to what we have. So, we're looking at Google Pub Sub, but at the same time, if we get to the point where we're trying to deal with dogma, we will then have to have a local MQ of some kind to deal with that kind of throughput and responsiveness.
Is this on Reddit yet? Should maybe get some actual comment.
Yeah, just go ahead and post it on Reddit, it'll be fine.
Real quick here.
Ah, Jesus. Are we still recording?
Great. Someone's probably already got it.
Yeah, well.
Oh, they don't?
OC. How many nodes do we have? Just 2?
4.
We have 4 pods. 4 pods. Yeah.
Yeah, what could go wrong?
Everything is fine.
No, I didn't actually. There is, if spam starts to get a little bit out of control, there's a couple things we can do, but it'll be fine. Whatever.
Content.
Yep. Cool.
Any other questions at all?
You have to use GiphyCat or Imager Giphies or YouTube.
What? Wait, does it autoplay? Oh boy. Yeah, we were originally telling Falcon about this, and he was like, "I love this idea. This is great." And he's like, "Should we get Seagull to say something in the keynote about it?" I'm like, no, do not. I think that's it. The end.
Yeah.
Enjoy toasting chips.
There you go.
No autoplay.
No autoplay.
Thank God.
For our sanity intact.
That and I don't want the paperwork, to be honest.
Right on. Unless there's any other questions, yeah, I think we're good.
And there's cookies.
There's definitely more cookies.
There's definitely more cookies. You could probably kill a man with this bag.